that I started my journey on recycled water something like 23 years ago when I arrived in Singapore to lead up all the foundational work that sat in behind what is now known as their New Water program. New Water being the name that they give to purified recycled water in Singapore. Yeah, they've got a bit of branding going on there. And here is just a couple of pictures of the work that we managed to complete while I was over there for a few years. And I was actually quite glad to report yesterday was the 20th anniversary of New Water going public in Singapore. So that's quite a milestone in purified recycled water. I think that sort of passed us by here in Australia, but I know in Singapore there'd be a number of people who have been paying attention to that. New Water is now the cornerstone of Singapore's water supply system, and it's very significant. It's about 30% of the daily water needs of Singapore at the moment. So yeah, and look, and you talk about social license. There's a lot of effort put into building visitor centres and a public education system as well around water cycle management. So I think if you ever get a chance to go to Singapore and you have a little bit of spare time, please drop by and have a look at the New Water Visitor Centre. I think it's hit about 4 million people visitation. So I wish I had ticketing rights for that, but sadly no. So the next slide, I'll just go back. No talk about treatment processes and would go, has to have an awesome diagram like this, right? And it's a complicated diagram, I admit, but what this is it's a spectrum diagram. It's showing the particle spectrum for things like what Simon was talking about, pathogens and microbes, all the way through to atomic things and salts and all those sorts of things there. So on the right-hand side there, you've got things that are visible to the naked eye, and all the way to the left are things that are at the atomic scale, and you'll need assistance from special electron microscopes to actually look at that. But what I wanted to draw your attention to was these three regions here in blue, in the blue and the orange here that I've marked out. Those spectrums there are really of great interest to us because they're the spectrums that new technologies has enabled us to start removing these particles as well. And that's the kind of breakthrough, as you could say, that has allowed us to make purified recycled water, especially on the scale of what Singapore is doing at the moment. Traditionally, we've only been able to get to the right-hand side of particle filtration, sand filters and all that sort of stuff. As you can see, it's going to be totally inadequate for making the water that we want and the safe recycled water that we want as well. So moving on to the next slide. Here is a couple of pictures of what I call the classic dual membrane separation technologies that we use to create purified recycled water. There's microfiltration, ultrafiltration, reverse osmosis, and ultraviolet light disinfection. These three technologies allow us to make purified recycled water. And how that goes together, well, we put these technologies or these treatment processes in series, and they operate kind of like this. So we have what I call used water, using the same words that I guess the Singaporeans use, but I kind of like that rather than using the word of treated effluent and all that sort of stuff. But in used water, we have a lot of these contaminants in there as well. And you can see in there how we string those processes together. There's overlapping treatment barriers there that allow us to remove things that we don't want in the recycled water. A long story short, this kind of treatment process is very comprehensive contaminant removal. It does rely on physical and chemical processes to do that. Unfortunately, it does make a very significant reject stream that we have to dispose of. And that's quite contentious. And it's about 30% of the water coming in that has to be, that is not usable. And this is the most commonly used process. But there's good news. There is alternative processes, and I think John mentioned that we're using advanced oxidation processes at Eastern Treatment Plant. And it's a very good example of the application of this technology. And again, this technology can be strung together. We have ozone with BAC filters or biologically activated carbon filters together with UV disinfection. And we can produce just about comparable water to the membrane separation processes. The only differences being is that we have a lot less reject to look after, which is great, but it also means that we have a salt level that is preserved or conserved in the system as well. And that's something that it's a technical nuance that needs to be discussed. I wanted to also talk about the opportunities we see coming up going into the future.
15 seconds, John.
Yep. And I'm just about there. So yeah, and we have lots of opportunities around where do we take recycled water in the future. You know, we're great about the drinking stuff, but I also think there's a lot to do around the industrial area as well, and in particular around how do we actually decarbonize ourselves and get ourselves off fossil fuels, which is where the hydrogen area goes in as well. And maybe if we could discuss that a little bit later on. And the other area that we're really encouraging is to see is that water authorities like Goulburn Valley Water are starting to have that conversation with their customers as well. And I think this is really important to start talking about what part do they play in the circular economy, and how do we start to close off these materials and energy loops that we've got in our systems as well.